Now we're ready for tree and Venn diagrams. Tree diagrams are a way to visually organize the probability for two or more events, and we can do them with both independent and dependent events. So in this first example, let's suppose a teacher gave a pop quiz that has 3 true or false questions. The answers to those questions are true, false, and false in that order. So in a tree diagram, we will give all of the results for each part of that test. So for example, in question 1, we have 2 options. We can vote either true or false. Well, let's say if we voted true, then we have 2 more options for the second question, true or false. And then if we voted true, we would have, true or false, true. So it identifies every possible path. So tree diagrams are great if you don't have too many options for each. Now, when we're using the probability, we can write all of the probabilities for each choice, for each option on the branches themselves. For example, in question 1, we have a 50% chance of the answer being true and a 50% chance of it being false. Or you can use fractions if you want. Same thing for question 2. If we answer the first question as true, well, that has no impact on the second question being true or false. So we have a 50% chance of being correct on the first one, or 50% chance of being correct on the false. Likewise, so we can fill out every single branch with its probability. Now let's answer some questions. The first question is, what is the probability that all 3 are correct? Well, remember, the correct answers were true, false, and false. So if we looked at the probability for each of those, we have a 50% chance of choosing the correct answer. Then we have another 50% chance of choosing the correct answer since there's only 2 options, and another 50%. So for all 3 to be correct, true, false, false, that's the same thing as saying 50% times 50% times 50%, which would give us 0.125 or a 12.5% chance. That's not very high, right? So the second question, which should be B, is the probability that none are correct. Well, if the first one is supposed to be true and we answer false, that's incorrect. The second question is supposed to be false and we answer true. And then the third question should be false, but we answer true. Guess what? We still get the same probability that we did before, 0.125 or 12.5%. Now, in the last part, which should be C, what's the probability at least 1 is correct? So if we think back, remember that the probability of at least 1 is the same thing as 1 minus the probability of none. And we've already found the probability of none in that second part there. So we can do 1 minus 0.125, which gives us 0.875, I believe, or 87.5%, which makes you feel pretty good. We have an 87.5% chance of getting at least one of the questions correct. In our next example, there are 10 marbles in a bag. 3 of them are red, 5 blue, and 2 green. So suppose we choose 2 marbles at random with no replacement. So imagine our first bag. We have 3 red, 5 blue, and 2 green. So in our first pick, if we were to pick red with our first marble, we have 3 out of 10 chance of picking red. That's the probability of our first marble being red. For blue, there are 5 blue marbles out of the 10. And for green, we have 2 out of the 10. But for our second marble, remember this is our first pick. Now let's take a look at our second pick. For the red, if we chose red first, we still have 3 possible colors for the second choice. If we pick red again, and remember it's with no replacement, that means one of the red marbles is gone at the second choice. So there are only 2 red marbles out of a total of 9. We still have all of the blues left, but only 9 marbles total. Green, we still have all 2 of the green, but again, only 9 marbles left. And then we continue for each of these colors. I'm going to do blue out a little bit further so we can see it a little bit better. If we picked blue, then for the red, we have all 3 red, but out of 9 marbles. If we already picked a blue, that means we have 1 less blue, 4 out of 1 less total of 9. And then green, we have all green left out of the 9. If you want to pause and see what you think the branches will be here for the green, go ahead. Otherwise, we have 3 out of 9. The blue is 5 out of 9. And the green, since we already picked 1 green, leaves us with 1 green out of 9. So now we're asked to find the following probabilities. The probability that it's blue and then green. So that's the probability that our first pick would be blue, times the probability that once we pick blue, our second one is green. So notice we stay along the track of the blue as the first, and then green means we have 2/9, which gives us 10/90, which reduces to 1/9 as our probability. If they ask for a decimal, you could put it in, and it's approximately 0.111 with the ones repeating, or 11.1% chance. For the second question, they're asking us what's the probability that our second draw is red, but given that our first one was red. So we're only asking for the probability of this one marble, given that the first one was red. Well, if the first one was red, that means that we are along this branch here. And if we already picked out a red one, then there is a 2 out of 9 chance that our second marble would also be red. And again, that's approximately 0.222 or 22.2%. Now, part C is a little bit different because it wants the probability that 2 marbles are the same color. That means it could be the probability of red and red, or the probability of blue and blue, or the probability of green and green. Well, if we look across, probability of red and then red will give us a 3/10 times 2/9. Remember, or is plus. Then we're looking at the probability of the first one being blue, and then the second one being blue. So that would be 5 out of 10 times 4 out of 9. The probability that it's green and green, we have those 2 possibilities, which would give us 2/10 times 1/9. Let me scroll up a little bit so we can write those answers down. That gives us 6 out of 90 plus 20 out of 90 plus 2 out of 90. This is why I didn't reduce anything, because if I do have to add them, I already have common denominators. So that gives me 28 out of 90, which reduces to 14 out of 45. And if we want a decimal, it's going to be 0.3 with 1 repeating, or 31.1%. So be sure you pay attention to whether or not they want it in fraction form or in a reduced decimal form to so many decimal places, or even in a percent form.